Welcome everybody. We've been given this question. Integers a, b, c satisfy a positive b negative c is equal to 1 and a squared positive b squared negative c squared is equal to negative 1. If a comma b comma c are all greater than 0, then we are expected to evaluate and obtain the value for this integral. Integral 0 to a squared positive b squared positive c squared square root of x squared positive 2x positive 5 times dx. Okay, so foremost our objective in this question is to find the value of a, b and c. We are given that a positive b negative c is equal to 1, which means a positive b is equal to c positive 1. Also we have a squared positive b squared negative c squared is equal to negative 1. So this means a squared positive b squared is equal to c squared negative 1. So I take this as 1 and this as 2. Okay, so what we can now do is square 1 both sides. So if I were to square 1 both sides, I would have a positive b whole squared is equal to c positive 1 the whole squared. If I were to expand this, I get a squared positive 2ab positive b squared is equal to c squared and positive 2 times c positive 1. Okay, fair enough. Now I can club this together, a squared positive b squared, and then you have 2ab, this is equal to c squared positive 1 positive 2c. Now from 2, a squared positive b squared is c squared negative 1, so I'm going to replace that, c squared negative 1 positive 2ab is equal to c squared positive 1 positive 2c. So c squared can be cancelled. Now is there anything else we can do? Okay, probably we can have a light substitution. So what I'm going to do before that, I'm going to push this negative 1 to the other side. So you have 2ab is equal to negative 1 will become positive 1. There's already one positive 2c. So this is 2ab is equal to 1 added with 1 gives me 2 followed by 2c. So I divide by 2 throughout. That would give me ab is equal to 1 positive c. But 1 positive c is what? A positive b. So this means ab is equal to a positive b. Now I wish to bring this a positive b to the other side. So you have ab negative a negative b is equal to 0. So what I want to do is I would want to club these two together, and I would want to also have some quantity with b, so that if I were to take this a out, I will have b minus 1. Right, so I need to have a b minus 1 also here. So if I were to place a b minus 1 here, negative b, okay, that is well and good. I have a negative b, but I have to get a positive, in fact I'm getting a positive 1, so I have to counter it with a negative 1, right? So positive 1 and negative 1 goes off, right, because of the presence of this negative 1 which we have added. So this is balanced. So now what I wish to do is I would take b negative 1 out. That would mean I get a here followed by a negative 1, and I have a negative 1 equal to 0. I'll push this negative 1 to the other end. So this means a negative 1 multiplied with b negative 1 is equal to 1. So this is what we've got. Okay, fair and good. Now from the product rule, ab is equal to 1, or I would say we have a product being equated to 1. So what are the other probabilities or possibilities that we can face here? We have this probability which is a negative 1 is equal to 1 and b negative 1 is equal to 1. Product of these two will result in giving me 1. Also there's other probability that a negative 1 is equal to negative 1 and b negative 1 is equal to negative 1, right? Negative 1 multiplied with negative 1 will produce me positive 1. Now if this is the situation, Okay, so let me write this down. If a negative 1 is equal to 1, then a is equal to 2 and b is equal to 2. So therefore 1, I'm talking about this 1 can be rewritten as, so a is 2, b is 2 and c is, I should say on the right hand side I have c positive 1. So this is 4 negative 1 is equal to c, therefore c is equal to 3. So clearly a, b, c, a comma b comma c are all greater than 0, okay, when I have this as my solution set. On the other hand, if I were to take a negative 1 is equal to negative 1, this also is a part of the solution, but in this case a will be equal to 0, b will be equal to 0, so we don't need this. But of course c is not going to be equal to 0 because c will be equal to negative 1, but we don't need this. Why we don't need this? For the very fact that our a, b, c should be greater than 0, okay, so only then we can give the evaluation for this. So our a is 2, b is 2 and our c is 3. So therefore the evaluated value for a squared plus b squared plus c squared is going to be 2 squared plus 2 squared plus 3 squared, which is nothing but 4 positive 9, which is nothing but 17, right? So we did all this just to find out the integral value. So hence integral 0 to a squared positive b squared positive c squared root of x squared, right? X squared positive 2x positive 5 times the dx is now 0 to 17 square root of x squared positive 2x positive 5 times dx. This is what we have got. So now our present challenge is to integrate this. Now what I wish to do is I would like to rewrite x squared positive 2x positive 5 as x squared positive 2x positive 1 positive 4. This is nothing but x positive 1 the whole squared, right? Positive 4 I'm going to rewrite it as 2 squared. So this is equal to integral 0 to 17 root of x positive 1 the whole squared positive 2 squared times dx. So let x positive 1 be equal to some u. This would give me dx is equal to du. So root of, you have u squared positive 2 squared times du. Now when x is equal to 0, what happens to u? When x is equal to 0, u is equal to 1, and when x is equal to 17, u is equal to 18. So this is the present limit. Now there is a formula, it's a standard formula. We know that integral root of x squared positive a squared times dx is equal to x over 2 root of x squared positive a squared over 2 ln modulus of x positive root of x squared positive a squared positive c. This is the standard formula. So by this formula, if I had to apply this formula over here, this is going to be u over 2 root of u squared positive 2 squared positive 2 squared over 2 ln of u positive root of u squared positive 2 squared. Now the limits are 1 to 18, okay, 1 to 18. So this is equal to, you substitute the upper limit 18 over 2 root of, this is 18 squared positive 4 positive, this is a squared, right, a squared, this is 4 over 2 ln modulus of 18 positive root of 18 squared positive 4. This is upper limit minus the lower limit, right? So the lower limit is going to be u, this is going to be equal to 1, right? So parenthesis and 1 over 2 root of 1 squared positive 4 positive, this is already 4 that is present, so 4 over 2 ln modulus of 1 positive root of 4 positive 1, that's going to be 5 there, so just write that out. Okay, so now we have to evaluate this limit. So let me go to the new space here. So this is equal to 2 divides here 9 times, 18 squared. What is that 18 squared? 18 multiplied with 18. 8 8s are 64, 6 and 14, 8, 1. And this is 4, this is 3 to 4. Okay, so you have 3 to 4 plus a 4 there. So this is going to be root of 3 to 8 positive 4, 2 divides here 2 times ln modulus of 18 positive root of 3 to 8, right, followed by negative 1 over 2 times the root of 5 negative 2 times ln modulus of 1 plus root of 5. So this is what we have got. Okay, so I can club this as 9 times the root of 3 to 8 negative root of 5 over 2 positive. I can take the 2 out. This is ln modulus of 18 positive root of 3 to 8 negative ln modulus of 1 positive root 5. So this 2 is LCM here. 9 2s are 18 times root of 3 to 8 negative root of 5. That's the value there. Plus 2 times ln A minus ln B. So it's going to be ln modulus of 18 positive root of 3 to 8. Okay, divided by 1 positive root of 5. Right, this is what we've got. Now this is the correct place or the right place for us to stop. If you want, you can use your calculator and get an approximation, but I think we can stop here. So this is a solution for this beautiful question, which involves algebra and integral calculus. Thank you everybody. Please like, share and subscribe.